Let's be honest. Forget the arguments on the internet and just ask one question. What if the Earth actually were flat? Not as a conspiracy theory, but as a physical scenario. Let's say it's true. The Earth is a disk. Flat, round, like a coin. What would then have to be true about the rest of the world? What would physics have to say? What would observations have to show? Let's check. Spoiler, every answer gets worse for this idea than the one before. Let's start with the simplest thing, gravity. Gravity pulls mass toward the center of mass of an object. On a spherical Earth, the center of mass is at the center of the sphere, which is why everything falls downward in the same direction for everyone on the surface. On a flat Earth, the center of mass is at the center of the disk. This means gravity would not simply pull things straight down. It would pull everything toward the center of the disk at an angle. The further you are from the center of the flat Earth, the more gravity would pull you not vertically downward, but diagonally toward the center. People living at the edge of the disk would constantly feel themselves being pulled sideways, as if standing on a sloped surface. Rivers would flow not toward the sea, but toward the center of the disk. All the oceans would drain toward the central point. The atmosphere would accumulate above the center and thin out toward the edges. We observe none of this. Nowhere on the planet is there a direction in which gravity pulls people at an angle to the surface. There are no rivers flowing toward the Arctic center. There is no difference in atmospheric density between the center and the edges of the disk. First test failed. If you think flat earthers have an answer for gravity, subscribe, because from here the problems only multiply. Second question, the horizon. On a flat Earth, the horizon should not exist in the way we experience it. The horizon is the line beyond which the surface of the planet curves away downward along the sphere. On a flat surface, you should be able to see infinitely far in clear enough weather, limited only by atmospheric haze. But we observe something different. Ships sailing out to sea disappear from the bottom up. First, the hull vanishes, then the masts. If the Earth were flat, a ship would simply shrink in size and disappear into the haze all at once. With altitude, the horizon drops. The higher you climb, the further you can see. This corresponds mathematically and precisely to the curvature of a sphere with a radius of 6,371 kilometers. On a flat surface, climbing higher would let you see further, but the horizon would not drop. It would stay at eye level. Pilots, sailors, and anyone who has climbed to sufficient height observes a dropping horizon. Every time, without exception. Second test failed. Third question, shadows and time. If the Earth is flat and the sun shines above it like a flashlight over a table, shadows should behave differently from what we observe. Two people standing 1,000 kilometers apart at the same moment in time should see the sun at roughly the same angle. Because on a flat surface with a sufficiently distant light source, parallel rays illuminate the surface equally. But this exact observation destroyed the idea of a flat Earth back in 300 BC. The Greek scholar Eratosthenes noticed that in Alexandria at noon, a vertical stick cast a short shadow, while in Syene, roughly 800 kilometers to the south, at the same moment a vertical stick cast no shadow at all. The sun was directly overhead. If the Earth is flat and the sun is far away, this is impossible. Different shadows at the same time of day at different latitudes are only possible on a curved surface. Eratosthenes did not just prove the Earth is round, he calculated its circumference to within a few percent. In 300 BC, third test failed. Fourth question, day and night. On a flat Earth, explaining the cycle of day and night physically is very difficult. If the sun shines above the disk like a flashlight, it should illuminate most of the disk simultaneously. To produce night on one half of the planet, while the other half has day, the sun would somehow need to illuminate only part of the surface. The flat Earth model proposes a sun that shines like a spotlight, only within a certain cone. But a spotlight with that cone would create a sharp boundary between light and darkness, with no gradual twilight, no long sunsets and sunrises at high latitudes, no white nights in Scandinavia. What we actually observe is precisely the opposite. Gradual transitions, long summer evenings in the north, very short winter days, all of which are mathematically and precisely described by a sphere rotating around a tilted axis. On a flat disk, Arctic white nights are physically impossible in principle, but they exist every year. Fourth test failed. And finally, the physics of the disk itself. Let's say the Earth is a disk. What is it made of, and why is it a disk and not a sphere? Any mass large enough, more than a few hundred kilometers in diameter, will, under the force of its own gravity, take the shape of a sphere. This is called hydrostatic equilibrium. Gravity pulls every part of the object toward the common center of mass with equal force. And as a result, the object takes on the shape where the distance from every point on the surface to the center is equal. That is, the shape of a sphere. Asteroids are small, which is why they have irregular shapes. Planets are large, which is why they are spheres. There is no known physical process that could create a stable disk of planetary size. If the Earth had originally been disk-shaped, its own gravity would have turned it into a sphere over millions of years. It would have compressed, redistributed its mass, and evened out its shape. Fifth test failed. The conclusion is simple. A flat Earth is not just an incorrect idea. It is an idea that requires all of physics to be wrong simultaneously. Gravity would have to work differently. Light would have to propagate differently. Planets would have to form differently. Shadows would have to fall differently. Day and night would have to change differently. Every single observation we can make with a ruler, a level, a ship, or a simple stick pushed into the ground says the same thing. Sphere. Physics does not vote. It simply calculates. And the result of those calculations was known before the first pyramid was built. If you want to see more breakdowns like this, hit like.